Hello, advanced algebra students. I hope you're doing awesome. I so much enjoy working with you. I know I kind of say the same thing every time I start off my notes, but it is so true. I really do love my job. I hope you're enjoying the class. We are in chapter 2 of our advanced algebra book, and in chapter 1 we were kind of generalizing, what are functions about and what are common patterns we see in functions, what are common ways of describing the behaviors or key features of functions. Chapter 2 is essentially about quadratics, and so far we've been talking for the most part about graphing quadratics. The first lesson was on graphing in vertex form. The second lesson was on graphing in standard form. Today we're going to talk about graphing quadratics that are in what's called intercept form. So at the top of your notes you should have 2.3a factored or intercept form of a quadratic function. Now the reason we have a 2.3a and a 2.3b is that in order to finish this assignment we're going to have to learn how to factor. So we're going to do what we can on chapter 2 without the knowledge of factoring, and then we're going to take a detour into the Algebra 1 book again to talk about factoring. After we've done that, we will come back to chapter 2 and finish off section 2.3, so we'll do lesson 2.3b at that time. All right, so let's just kind of write at the top of our notes the factored form of a quadratic equation would be f of x equals a times the quantity x minus p times the quantity x minus q. So if we have our quadratic function in this format, the x-intercepts are going to be at p and q. So p and q will tell us the x-intercepts, and a means the same things it always does. If a is positive, our parabola opens up. If a is negative, it opens down. If a is bigger than 1, we stretch the parabola. And if a is between 0 and 1, we shrink it. So the a means the same thing it always does. In this case, we now have, instead of say an h and a k, or an a, b, and c, we have a p and a q. All right, so let's talk about how to graph a parabola, and we can either call this factored form or intercepts form. They are interchangeable. So for example 1, we are going to graph f of x equals x plus 1 times x minus 3. Now, I personally think that this is one of the easiest methods to work with. In this particular case, it can be helpful to think of this as x minus negative 1 and x minus 3. And because we're just starting out, if it will help you, we can write this as x minus p times x minus q underneath it and kind of line everything up. If you do, you can see that p is negative 1 and q is positive 3. So what that means is we have intercepts for this parabola at negative 1 and positive 3. So we're going to put the intercepts there. Now, the first step when we're graphing is obviously to plot and label the intercepts. So we could label this, for instance, negative 1, 0, and 3, 0. The second step is going to be to draw and label the axis of symmetry. Now, the axis of symmetry is always going to be exactly down the middle between the two intercepts. So because there's 4 units between these two intercepts, I want to go in 2 units from either direction, and I can see that the line x equals 1 will be my axis of symmetry, and I know that my vertex is going to be on there. Now, to find out where on this line it is, I simply plug in the information I have from my intercepts. So my equation is f of x equals x plus 1 times x minus 3. And then I can plug in the points that I have. So if I plug in f of 1, if I want to evaluate the function when x is 1, I'm going to be taking 1 plus 1 times 1 minus 3, which is 2 times negative 2, or negative 4. So that tells me that my y coordinate of my vertex is at -4. So this is the point 1, -4. And this is considered complete when you're graphing a function in intercepts or factored form to indicate the two intercepts and the vertex, label all three of those points and label the axis of symmetry, and that is considered to be a complete graph. All right, so as I said, I think this format is a lot easier than graphing in standard form. Now we're going to talk about something that can occur sometimes when you have just what looks like one parentheses. So let's do example number 2. Let's graph f of x equals x minus 2 squared. Technically, we could think of this as being in vertex form as well, but for purposes of this lesson, let's go ahead and think of it as just x minus 2 times x minus 2. What happens when we have two parentheses that are the same like this is it means that we do indeed have an x-intercept at 2, but in this particular case, the function is going to drop down and hit the x-axis at 2 and then bounce right back up again. So it only has one intercept, but that intercept is 2. If your A is positive, the parabola is going to end up opening up. If the A is negative, then the parabola would end up opening down. If I wanted to find this y-intercept here, an easy way to do that would have just been plug in 0 for x. So if I plug in 0 for x, I have 0 minus 2 squared, which is -2 squared, or 4. So that's how I knew that the graph went through the point 0, 4. So if you see something in the format x minus a number squared, then you can either think of that as being in vertex form and the vertex is at 2, 0, or you can know that whenever you have a factor like that to the power of 2, it means that the graph touches at that spot but doesn't go through the x-axis. It'll either be all above or all below the x-axis. Okay, now let's talk about how you can write an equation in factored form if you are given the information. So let's make this be example 3. And in this example, we have x-intercepts of -2, 0, and 3, 0, and another point at 0, 6. So this is very similar to what we did with our other formats. We want to label the information that we've been given. So we know that this is our x-intercept of P and our x-intercept of Q, and then this is going to be x and y, and actually we don't really need to put those letters there. So one of our intercepts is P, the other intercept is Q, and then the point, we're just going to label x and y. So we go ahead and write our general function. So y equals a times x minus p times x minus q. And what we're trying to do here is to find the a, just like we did with the other two formats. So we want to plug in everything that we have. We plug in 6 for y. We don't know what a is, so we're going to leave it like that. We're going to plug in 0 for x, and then we're going to say minus -2 for x minus p, and then x minus 3 for the other intercept. Here, this becomes positive. Oh, and wait a second, x should be 0, and then that'll be -3. So I have a times 2 times -3, or 6 equals -6a. When I divide both sides by -6, I get that a is -1. Now I'm ready to fill in the equation because I have a P, I have a Q, and I have an A. So I can write, if it is more helpful to me, I can write the general format here. And then just plug everything in. So y equals -1 times x plus 2 times x minus 3. So that's how we would come up with the equation if given the information. Okay, so that was example 3. Now what I would like to do is one more example with you, and I'd like to do a word problem. This is similar to one that's on your homework and maybe one on the test as well. This will be our last example, example number 4. And just like with before, I'm going to read this problem, and then you don't have to write down all the words, just write down what I actually put on the board. So let me go ahead and read it for you. And I love this problem because it talks about prairie dogs. And every summer when I ride my motorcycle, I go to South Dakota, and in Custer, or near Custer, they have fields full of prairie dogs, and they are the cutest little things. If you guys remind me, maybe I'll try to find a video of one to show you during class. But anyway, this is the way that the problem reads. A prairie dog burrow has openings to the surface, which, if graphed, correspond to the points -5, 0, and 1, 0. So I'm going to graph those points. I'm going to go 5 to the left of the origin and put a dot at -5, 0. And then I'm going to go 1 to the right of the origin and put a dot at 1, 0. And then it says, what equation models the burrow if at one point it passes through the point -1, -8? So let's see here. Actually, you know what's interesting? I think that I changed this to be -2, -9. So let's run with that. Let's write goes through the point -2, -9. No. I think that's just going to be part of my answer. Okay, I'm going to back up. It does go through the point -1, -8. I just didn't have it on my graph. So let me change that. I think the vertex ends up being -2, -9. So let's have it go through the point -1, -8. Let's graph that. 1, 2, 3, 4, 5, 6, 7, 8. All right. So this is not the vertex, but it is a point on the graph, -1, -8. All right, so this is going to be our P, this is going to be our Q, and then this is just going to be an X and a Y. And we want to come up with the equation. So this is very similar to the problem we just did. We're going to write the general format here, Y equals A times X minus P times X minus Q. We don't know what A is, but we're going to plug in the X, the Y, the P, and the Q and find A. So we're going to write for Y, -8 equals A times, and then X is -1. Our P is -5, so -1 minus -5 times -1 minus 1. Then we get -8 equals A times 4 times -2. Or -8 equals -8A, or simply A equals 1. So now we've got that A is 1. We know our P is -5 and our Q is +1. And so we're going to write the equation using that information. So we're going to write Y equals 1 times, because 1 is our A, and then X plus 5 times X minus 1. And then if we wanted to find the vertex on this, we would need to find where the middle of these 2 points would be. So if we're going from -5 to +1, that's 6 units. So if I want to go 3 in from either end, 1, 2, 3, that's where I got my -2 from. So the axis of symmetry for this graph is X equals -2. So if we want to find the vertex for graphing purposes, we would need to plug -2 in for X. So we would write Y equals 1 times -2 plus 5 times -2 minus 1, or Y equals 1 times 3 times -3, or Y equals -9. So what we can see is the vertex is at -2, -9. So what we went over in this word problem is how do we graph the picture that we've been given, and how do we also come up with the equation for the information we've been given. All right, hopefully that was helpful. I hope you're having a great day, and I'll see you tomorrow on Zoom. Bye.